just in case you can't tell by listening to my accent, I'm from the South. And in the South, sweet tea is a staple. The only problem is sometimes people make it far too strong for me. It's very dark brown and very thick with the sugars, and I don't like it that way exactly, so I'll put some water in there to dilute it. Well, we dilute things a lot of the time in the chemistry lab, but when we dilute it in the chemistry lab, we need to know exactly how dilute or how concentrated the resulting solution is going to be. And that's what we begin to learn about in this lesson. So there's a plug and chug kind of formula for dilution, and we'll get to that later. So right now, I simply want to cover what dilution is in a little more in-depth way. All right? I want to talk about what it is, what it means when you dilute a solution here, and do the math that goes along with that. What? If the solvent is water, yes. Okay. You always add more solvent, but we're going to calculate what the new concentration is when you do the dilution. All right, that's where we're going to start. So you've got the basic idea here. If extra solvent is added to a solution, you add the original solution volume to the volume of the added solvent and recalculate the concentration. Okay? So if extra solvent is added to a solution, you add the original solution volume to the volume of the added solvent and recalculate the concentration. Okay? I'm going to give you a homework problem first, and I'm going to show you the steps for solving a problem such as this. What is the new concentration if 100.0 milliliters of a 1.50 molar potassium chloride solution is diluted with 50.0 milliliters of water. Okay? So the homework problem is, what is the new concentration if 100 milliliters of a 1.50 molar potassium chloride solution is diluted with 50.0 milliliters of water? So the example we're going to use here to see how to solve something like this is this. We're going to have a volume of 15.0 milliliters of water, okay, added to 25.0 milliliters of a hydrochloric acid solution that has a concentration of 1.0 molar. Okay? So what we've got to do here is to figure out how many moles of hydrochloric acid there are in this original solution, then add up the volume of the original solution with the volume of the solvent and recalculate the concentration. Are you with me? That makes sense? We're doing? Got to find how many moles of solute there are, Then we're going to add the solution volume to the volume of the solvent we're adding to it. And then we're going to recalculate the concentration. To find the number of moles of HCl there are in 25 milliliters of a 1 molar solution, we take the molar concentration, the molarity, and split it out into its separate units. 1.0 moles of HCl in 1 liter of HCl solution. And if we multiply that by the volume in liters, we'll have just the moles. The only problem is we don't have the volume in liters, we have it in milliliters. So instead of multiplying it by the volume in liters, we could convert first, but I want to do it as one problem. I'm going to take that 25.0 milliliters of HCl solution, multiply that, but I'm going to just add in a conversion because I know there are 1,000 milliliters in 1 liter. And so I want 1,000 milliliters in the bottom here and 1 liter on the top here. Some of you missed a lot of points. Some people missed a lot of points on the test because they weren't doing the dimensional analysis. So be careful that you do this. Liters are going to cancel here. Milliliters cancel here. HCl solution cancels out. Okay? All we have left are moles. This is going to allow us to calculate moles. And the dimensional analysis is showing us that's what we're going to get. And we do the math, we get 0.025 moles of HCl. Okay? The reason we're doing this is we know that molar concentration is moles of solute over liters of solution. Okay? And we have the moles of solute here broken out. Now we're going to take and we're going to add together the volume of the solution to the volume of the added solvent. Okay? So our original solution had 25 milliliters in it. 25 milliliters of solution, of this HCl solution. Okay, we're going to add to that the volume of the water. That's the solvent here. I could say H2O, I suppose. And we'll get 40.0 milliliters of this new or diluted solution. Okay? So we're going to put it all back together now. We're going to take this moles of this and put over liters of this, but this isn't in liters yet. You can convert it to liters first, or you can do it all as one problem. Take the 0.025 moles hydrochloric acid and put it over the 40 milliliters now, the new volume of this HCl solution. Or I could say new HCl solution. So we've got to have it in liters to have molarity. Molar concentration comes in moles of solute per liters of solution. So I've got to convert that. We already have an equality statement here. 1,000 milliliters over 1 liter. Milliliters are going to cancel. .625 molar HCl solution. Round that off to 2 significant digits because I've got 2 here. .63 molar HCl solution. That's the answer to this example problem. Now, the basic idea is, in order to find out what the new concentration is when you dilute a solution, you've got to break out how many moles there are in the solution, add the solution volume to the volume of the solvent added to it, and put your concentration unit back together. Okay? So we broke out and found out how many moles of HCl there are using this process right here. We took the original concentration, multiplied it times the volume of that solution. We had, in the problem, we have, in this problem here, we had 25 milliliters of this solution. Okay, so we multiply this out 25. We have to convert the liters to cancel out liters, and that gives us the moles. Then we put the moles over the total concentration, the total volume of the solution plus water down here to get this new concentration we have.